With that warm up, I think you can all see that number one is a little more in depth, a little more challenging. It's not that different from a couple that you did, but the numerator might cause some issues. So we shall see. So if you would consider, and I want you to actually show some steps here, right? So like before, it was more of just like a quick answer. See if you can consider some steps on this one. So I don't know if it's alternating or not, because
alternating, but it like goes between positive and negative.
there's going to be some pluses and minuses, right? Because sine is above and below the x-axis depending on what part of the graph you're on.
So should we start by proving that it's an alternating series?
So what I tend to do here with these, when it asks me, is it absolutely or conditionally convergent, my first move is actually to take away the pluses and minuses and see what happens, because if I take away the pluses and minuses and I get convergence, I'm done. I'm really hoping for that, right?
This isn't like.
There's pluses, it's not plus minus, plus minus, plus minus, but there are pluses and minuses. It might be plus, plus, minus, plus, 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 minus, minus,
So looking at the pluses and minuses, would you do the absolute value or do you just?
Yep, you do the absolute value. So the absolute value of the whole thing, you take away any of the pluses and minuses that might have been there. Oh, I bet you can do absolute value. I hope you can.
I don't know what reasons, like I know exactly what's going on, but I don't know what reasoning to use.
This one is hard that way, like, so you're gonna have to call, I think you're gonna have to call in some older, not that old, like in the last couple of weeks, concepts to get there. See if you can put a few things together.
Can I just like say that the absolute value of something will never exceed one?
Of course you can, but then how do you use that?
Well, then it's just.
Severely overestimate my abilities.
Can we do?
Yeah, I'm open to what your suggestions might be. I have one path in my mind, but there could be others. I don't know.
Well, the thought is that since sine will only, it goes between -1 and 1 and it'll never exceed that, but it also will go less than 1, which will make the output less than, which means that if it was just 1 on the top, or -1 to the end, no, just 1 on the top, not -1 to the end. So
Like I said, if I were you, I would take all the pluses and minuses away and make it all positive to begin with. I really would.
So I definitely know that the one without the absolute values converges.
What if?
Right? Because it always just goes back and forth. So whatever you're adding, you're just going to subtract when it goes below the x.
Not necessarily.
So here's the thing, like, you guys are all thinking some good conceptual thoughts, and you're saying, well, the graph would do this, and the pluses and minuses would do that. We want you to be a little more precise in that, right? So yeah, you have the right ideas, but let's think about how you can formulate your thoughts and actually get them down on paper and use something that's recognized instead of like, because you guys are doing better than this, but like essentially in the math world, you're saying, well, that stuff with the thing and the plus and the minus deal, and so you get it, right?
Yeah.
You know what I mean? So like we want to like narrow this down to where it's like, this is unarguable. It must be this way. Yeah.
Can I take, not the bottom, but just the top, can I take the limit as n goes to infinity of sine of n?
Well,
Can I just like,
what would you get if you did the limit as n goes to infinity of sine of n?
well, it would never exceed 1, so I would just put 1 in there.
It'd kind of just be like bouncing back and forth between -1 and 1. So you said, so can I just put 1 in there?
If it's the absolute value of sine of n. Well,
Try it, so-
is it wrong though?
Kind of.
Well, it maybe depends on what you do with it from there. It might be good, it might be bad. But what you can't do is you can't just say, well, these are the same.
Because it goes back and forth. It's like
Right.
continuously.
But you
The average would be
could,
0.
The average.
the average would be 0. But if you just do, and I think this is what you said, if you just go limit as n goes towards infinity of sine of n,
Yeah.
like that's
Or
all
the
you-
absolute value of sine of n, just so we can
Okay.
take away the negatives.
So what is this equal to? What does this limit?
Anything.
Equal anything from.
What doesn't it equal though?
0.
It doesn't equal 0, does it?
Ah.
What doesn't it?
doesn't sine or absolute value of sine, whichever one it is, doesn't it basically just do this
Yep.
forever? So there is no like one value where it kind of starts narrowing down towards.
Like the summation of.
So I would say that if all we looked at was just the numerator, I would say that that diverges based on the nth term test, because we didn't get 0, so, but you can't ignore the denominator, right? So this would not be conclusive proof of anything for this one.
Okay, I just want to be able to kind of get it to where I can maybe just put 1, or I can get it to 1 over n squared and then,
That would be so lovely because that's
Okay.
really easy to deal with, right?
right,
So it's just a question of,
how do you get there?
yeah, you can't just say, well, I want to replace sine with 1 and just say they're the same.
Yeah,
What could I do?
So if you were to put limit as n goes to infinity of the absolute value of sine of n over n squared, it still wouldn't equal 0, because the numerator never equals 0.
Well, I think with this
Well, the
though,
absolute value of n squared.
well, that's going to be positive no matter what. We don't
Yeah.
really get. I think we could say this.
How?
Because the denominator, so you know the numerator is going between 0 and 1, or negative 1 and 1, whichever it is. So the numerator is going to be a real number. The
Yeah.
denominator is getting big without bound. So whenever the numerator is some constant, in this case between 0 and 1, numerator,
Oh,
the
isn't the
denominator is
limit
getting
of-
huge, this equals 0. But remember, if the nth term goes to 0, that tells you
Nothing.
nothing. So even though I think we could probably say this, it
Oh,
didn't
wait.
help us.
Do we have to? It's so annoying. Do not. Do we have to do the
Yep,
integral
yep.
test?
The what test?
no.
I would.
Ultraviolet
The integral
Shut
test would be, yikes. That would be interesting because of the, it would be n to the negative 2.
Right,
Well,
that'd be
now you're
fun.
thinking. Too bad we haven't learned that yet.
Boy, that would be very interesting. We could explore that. I would not consider that to be the easiest way. I really like what a couple of you did. Like you were pretty vocal about this too, Logan. About, man, if only the numerator was just a 1, this would be so much easier, right?
But
Because it can never really do anything past that.
alternating. Can you take out the sign of it? Because we always take it out.
You can't really. He's got a variable, so you can't just like you're out.
But no, but like
Take the
negative 1 to
inverse
the
side of
n
it.
has a variable too, and we just take it out.
Well, we absolute value it and consider the result, right?
Which will always be 1.
Okay, I think I have an idea, ready?
Yep.
Watch your
The
mouth.
absolute value of
I
sine.
said that from 1 to infinity, I said that negative 1 is less than sine of n, which is less than 1.
Okay, so let me start writing here because you're starting to give some details. So you said for
Interval 1 to infinity, which is the interval of order.
1 to infinity,
This is stupid.
Negative 1 is less than or equal to sine of n, which is less than or equal to 1.
so far true.
Then I said, and I did the absolute, I said sine of n. Then, okay, so the next thing that I did is then I brought in another series. I said the summation from 1 to infinity of 1 over n squared, and I just proved that that converges.
So I'll do that real quick. So that converges P series P equals 2, which is greater than 1.
Right.
Okay.
Then I said that the summation, since I know that the summation from 1 to infinity of 1 over n squared is a constant because it converges. I said that 1 over n squared is the summation from n equals 1 to infinity of that, 1 over n squared, is greater than the summation from n equals 1 to infinity of sine of n over n squared.
Usually get better than
Are
me.
you doing the
I don't know if
limit
you do that.
comparison if, like,
That's the word comparison.
it's a comparison, yeah.
It's a comparison. He's trying to get to a comparison test,
Okay.
which I really like.
Yeah, no, it's like.
So I was kind of thinking, the only thing that I would do here perhaps would be to, I like your reasoning, because obviously the conclusion now would be, well, if the thing that I'm comparing to is bigger than the thing I'm looking at, and the thing I'm comparing to converges, then my series would have to also converge. I'm thinking maybe I would say something like sine of n over n squared is less than or equal to 1 over n squared on 1 to infinity? Like I would just directly address the full series element, not just the numerator.
That's not always true though.
It's not?
No.
Why not?
Not when sine of n equals 1.
Oh, sorry. Oh, less than or equal to,
Ah,
right?
gotcha.
And even if we put the absolute, I was going to add those absolute values in there. So, and this would be a direct comparison, right? We're saying the series we're looking at, the nth term is always less than or equal to this other one. And then I would say the same thing that Jack just said, where we already know the convergence of that one. And so, Logan, where you're like saying, I really want this to be 1 over n squared. Well, me too, and we can compare to that.
Okay,
We're in good shape.
gotcha.
So then if this is true and that's true, then we can say therefore our original series I'll put the absolute values in there, converges.
Absolutely.
So I left the absolute values in there, therefore I can say therefore. Thank you, Sasha. Hey, Sasha, before you go any further, will you go back and look at your test and please double check and confirm that you have answered all of the multiple choice questions? I asked your classmates to do the same thing, and there was like 3 of them that were like, oh, I'm so glad you told me that because I left one of them blank. Yeah, so therefore, if you take away the pluses and minuses, you get convergence. That means if you put them back in, we still get convergence. That means we have an absolute convergence here. Thanks, Sasha.
Thanks, Sasha.
Bye, Sasha.
Bye, Sash.
So her name turned into salsa. Okay. Okay, so does that make sense? Like this, I told you this one would be a little more complicated because like I was thinking we'd go to comparison, and it's been a little while since we did that to try to like bring that back in, just to gain a little bit of fluency here. But you don't get what?
I think I'm scared.
You think you're scared? You do want to be fluent here. Like what you can't do is you can't compartmentalize and say, well, the integral test was a week and a half ago, and now today we're doing the ratio test, and I can't be expected to remember that integral test or geometric series test. We want to be able to like mingle them all together and say, all right, well I can like work through this, and that didn't work, so I'll go this other route. That's where we want to go. Okay, so I think I want to do one more. And let's see here. We did number 2 in the video. We did not do 3. We did 4. So 3 or 5. Let's do 3. Let's do 3.
Awesome.
Oh shoot, we have to do an
Okay.
Think about
Wait, can we just state the rules of which function grows faster?
Yeah.
so that's not a great like rigorous.
Okay.
I know this rankings thing, and this one does this, and that one does that. You know,
Yeah.
I think you can express it fairly simply, using that as kind of like your thinking to get somewhere.
Okay.
I'm being a little
Yeah.
bit vague on purpose.
No, I got you.
Are you thinking of the...
Like if you've got this thing over here and you got this thing over here, you know, as long as like this is just a number over here, I'm not that hyper concerned about the steps in between.
Yeah.
That makes sense? I am being vague on purpose.
I keep it vague. Wow.
Feels like that. It feels like the...
I'm pretty sure they have a term test.
Oh, true. Yeah. They always
So what do you guys find if you took away the pluses and minuses?
It definitely diverged.
Definitely diverge. So if I do sigma from here to here, I take away the pluses and minuses, I just get this over that. Jack says it definitely diverges. What reasoning would you use to prove that?
The nth term.
So if I look at the nth term test, the limit as n goes towards infinity of this over this. Bless you. I've got a factorial over a exponential. Factorial wins, right? So what's the answer to this limit?
It's a constant.
Not a constant.
It's not zero.
Heading towards infinity. Yeah. Heading towards infinity. And what's the most important thing about infinity here?
It's not zero.
It's not zero. So if you wanted to put something like that, I think that'd be a wise choice. Say, well, that number, not zero. Therefore, this series right here diverges. What does that mean about the original series? Like, what if you put the pluses and minuses back in? What's going to happen?
You don't necessarily.
I think we do know.
I think it's still divergent.
Here would be an example of a graph of the original series. So if I've got negative 1 to the n times n factorial over 2 to the n, the first term
Oh, I'm stupid.
N factorial goes fast.
the first term would be here,
Factorial is the
and then it would be here, then it would be here, then it would be here, then it would be here. And wouldn't we pretty soon be off the screen? There's your terms, right? Above, below. Above, below. Up, way above, way below.
Okay.
Right? So these terms are not decreasing in absolute value towards zero,
So.
which is what we would need.
Doesn't it if it's without the condition, then does it work for
But
both? Or is
let's
it-
think though, like, even if I put the pluses and minuses back here, so the pluses and minuses, this is a clear alternating series, right? So here's what I would have to do to prove that the alternating series converges. Wouldn't I have to say, I'm going back up to here, and I'm saying, all right, limit as n goes towards infinity of n factorial over 2 to the n. This is the first part of the alternating series test, isn't it? And this equals, well, I already proved this. For the alternating series test, what does this limit have to equal?
Zero.
It's got to equal 0. So I don't even really need to do what I just did in red there because I already did it in blue. The alternating series test here is going to be silent because the terms don't decrease in absolute value towards 0. So I'd have to go back and say, wow, okay, what does that mean? Or I look at the nth term test and I see that the terms are definitely alternating. There's no doubt. But they're going from here to here to here. Do you see how they're getting further and further away from the x-axis? Or I guess the n-axis, I guess. And so this series just diverges, whether the pluses and minuses are in there or not. The series just diverges.
Because as for what you say.
Nth term test. The terms, whether the pluses and minuses are in there or not, the nth term test doesn't go to 0.
Okay.
So even at, so for any alternating series.
The terms have to decrease in absolute value towards 0 for it to be converging.
That's the.
Think about the partial sums, right? Like the partial sums for this series that I've graphed up here, the partial sums, like the first one would be 1, and then you'd go minus 1/2 plus.
You just say that it doesn't equal 0.
It has to be that it just doesn't equal 0. And this is where the terms start to get really gigantic, right? Because this would be, so that was 2, so 3 would be, so we're up to 3/4 now. We're starting to see this build, right? Because 3/4 is bigger than 1/2. The fourth, it would be 24 over 16. And now you can see that those terms are getting further and further and further away from the x-axis. You get diverging for this one, yeah.
Okay, so the alternating series test, if you take the limit as n approaches infinity of the series, and it doesn't equal 0, then you don't know if it converges.
No, you do know by the nth term test, diverging.
So you just automatically know that if,
Because really that nth term process is the first, remember how I said that the alternating series test is kind of like the soccer mom? Like if you can just get on the team, you get the juice box and the medal and all that stuff.
yeah.
And so the nth term test is kind of like the getting on the team, right? Remember, it's the coach that's just like, they're just going to be mean. So if you can get past the mean coach, soccer mom's good with you, right? And so, yeah, if the nth term test, if the player fails the nth term test, it just diverges.
No, we don't actually have to know what the limit as Endoverse Infinity is, we just have to know that it's.
Not zero.
Whether it's absolute value or not, so just hybrids.
Yep.
Thank
Thank you guys. Have a good day. Well, you could like drive around him and shoot a lamp or something. The question is, could you draw a charge from LeBron James for playing?
Yeah, then sure.
I was like, with massive bodily injuries.
I mean, I would just.
hungry.
Yeah.
So they're like, there's only 2 schools in Big 12, Big 10 that have a lower head coaching salary.
Really? No.
And I don't know, one of them was like 2 million, and the other one was Penn State. It's like 680,000, which is a lot of money. But when you compare it to people that are making like 6, 7, 9, 10 million, I was like,
That has to be remaining budget then, because I know that James Franklin is on anywhere from like 6 to 7 million a year until like 2026. So that's got to be remaining budget.
it seemed like a typo. I'm like, surely Penn State pays more than that. 'Cause it's like,
Oh, no, yeah,
it's going to be like a top 10, like most desirable coaching position for college coaches. You know? I mean,
James Franklin is like top 10 in the nation, highest paid coaches. He's making probably almost 10 million a year. At least over 5.
Right, yeah. Anyways, I thought you would probably know about that.
Yeah, if I would have seen that, I would have really.
Yeah, I was like, right, yeah.
I came up here at 10:15 and you were teaching and I didn't want to barge in.
Oh, you can always just barge in. Like, yeah, I'm not that formal. I'm not going to get upset with you. I hope you wouldn't think that I would get upset with you.